everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. आज हम ऑपरेटिंग सिस्टम की क्लास करने वाले हैं जिसे हम ओएस कहते हैं। इसकी क्लास की अगर हम बात करते हैं तो 20th क्लास है। ऑलरेडी हमने 19th क्लासेस कर लिया है जिसमें हमने यूनिट 1 की बात करें। अगर हमने यूनिट 1 कंप्लीट कर लिया, यूनिट 2, यूनिट 3, यूनिट 4 कंप्लीट कर लिया है। आज हम जो स्टार्ट करेंगे वो यूनिट 5 स्टार्ट करेंगे एंड दिस इज द लास्ट यूनिट विद रिस्पेक्ट टू द ऑपरेटिंग सिस्टम सिलेबस हियर. And now we'll start with unit 5, and the unit 5 is your input output management. So where we will start with the first topic here, memory mapped input output. तो आज कोशिश करेंगे हाफ ऑफ द यूनिट या फिर वन बाय थर्ड ऑफ द यूनिट जो है वो हम ऑलरेडी डिस्कस कर लें। हाफ ऑफ द यूनिट तो ऑलरेडी हम कंप्लीट कर ही लेंगे। फर्स्ट ऑफ ऑल, अगर आप हमारा चैनल फर्स्ट टाइम देख रहे हो या अभी तक आपने हमारे चैनल को सब्सक्राइब नहीं किया है, इट्स अ ह्यूज रिक्वेस्ट कि आप हमारे चैनल को सब्सक्राइब करो सो दैट हम जो भी वीडियोस डालें वो आपके पास सबसे पहले पहुंचे। एंड सेकेंडली, अगर आपको हमारा वीडियो अच्छा लगे तो प्लीज़ हमारे वीडियो को लाइक, शेयर और सब्सक्राइब करो सो दैट ज़्यादा से ज़्यादा लोग के पास वीडियो पहुंचे और ज़्यादा से ज़्यादा लोग इसका यूटिलाइजेशन भी कर सके। Respect to the memory mapped input output. Memory mapped input output क्या होता है? That's basically instead of having a special method for accessing the values to be read or written, just get them from the memory or put them into the memory. The device is connected directly to a certain memory location, which we will discuss here by the diagram as well. If I'm talking about the memory mapped input, you have to use that when using the memory mapped input output, the same address space is assured by the memory and the input output devices. Some addresses represent memory cells as well as while other represent the registers in the input output device. No separate input output instructions are needed in the CPU that uses the memory map input output. Instead, we can perform input output operation using any instruction that can reference as a memory here. With regard of that, if I'm talking about the input output devices and memory share the same address space. Each input output devices is assigned a unique set of addresses. When the processor places a particular addresses on the address lines, the device recognizing this address responds to the command on the control lines. We will discuss moreover regarding to the memory mapped input output. As I told you many of the things, memory address XFFF, this is a 4 time F and the 4 times 0 here, and above is for input output devices. The register is used for the input output devices. The register is used by the device controller, which we'll discuss here in the figure. These registers are given a memory addresses. Memory is attached to the bus. When the bus sees certain addresses, it knows that they are memory addresses, but all the addresses for the accessing the input output devices here. वो memory addresses जो होते हैं वो primary memory as well as device 0, device 1, device 2, device n, जितने भी number of devices होते हैं वो सारे उससे होते हैं और ये they are connected, interconnected by through the bus. Their memory is allocated to the bus, and they know that the buses that sees certain addresses as well. So this is the figure what I'm talking about, the memory mapped input output here. This is the memory address here. This has been gone to the primary memory either in the device 0, device 1 until the device n here. जितने भी numbers of devices होंगे और they are connected to one another, and they had gone from, they are attached from memory addresses here. With this is the memory mapped input output that a figure that you can mention in your examination paper as well as a reference to this only. If I'm talking about, the processor requests either a read or a write operation, and the requested data is transferred over the data lines. Any machine instruction that can access the memory that can be used to transfer the data to or from input output devices. Well, with reference to that, with the separate device addresses, each component in a device has a two components address. One address is that a device address, and the other is the address of the command. एक आपका device address होता है, okay. The first will be the device address, and the second will be your that is the command addresses, command component address. That's like you can say that address of command. Okay, so second आपका होता है address of command here. Okay, with regard of that, the status and the data are registers with devices, and the devices are associated with the logical primary memory addresses rather than having a specialized device address here. So we'll go ahead with the following points with reference to that. The first point we will have to discuss here is memory mapped input output reduces the number of instruction type in the processor. तो जितने भी मेमोरी मैप्ड इनपुट आउटपुट होते हैं वो आपके रिड्यूस करते हैं नंबर ऑफ इंस्ट्रक्शंस टाइप को जो कि आपके एक्चुअली प्रोसेसर में एग्जिस्ट करते हैं. With regard of this, if I'm talking about the memory mapped input output here, we'll discuss more further points with related to the memory mapped input output that are referenced to the you just they had asked you about the short notes, write down or the short notes upon memory mapped input output or the direct access method for a file. So these were the direct access methods that are used by the file here. So here the second point we'll discuss here is, so we have the second point with reference to that, no special protection mechanism is needed to keep user processes from performing input output. So कोई भी special protection mechanism नहीं use होता है that is needed to keep the process from the performing the input output as well. With regard of the third point, every instruction that can reference memory can also reference the control register as well. जितने भी instructions होते हैं वो अगर आपका memory को reference कर रहे हैं तो that also can reference the control register as well. Now we'll discuss the difference between the blocking and non-blocking. Blocking और non-blocking का बीच में difference क्या होता है, that what we'll discuss here. In the blocking and non-blocking, if I'm talking about these two, so blocking and non-blocking, where in terms of the blocking and non-blocking, most input output requests are considered blocking request. ज़्यादातर आपके जो input output request होते हैं वो आपके blocking request ही कहलाते हैं, meaning that control does not return to the application until the input output is complete. Using system call, that block is sometimes called synchronous programming, where we can say that in terms of the blocking here, blocking input output system calls do not return until the input output is complete. Non-blocking input output system call return immediately. तो blocking input output call जो होती है वो कभी भी return नहीं होती input output जब complete हो जाता है. But in the case of the non-blocking input output जो system calls होते हैं वो return होते हैं immediately. With reference to that, with a blocking input output process is moved to the wait queue when an input output request is made and moved back to the ready queue here that when the request complete, allowing other process to run in the meantime. तो basically क्या होता है, blocking input output process जो होता है वो आपका move करता है waiting queue के through जिसमें input output request जो made की जाती है, and basically that move back to the ready queue, and as well as that request completed, then they're allowing those other process to run to the meantime as well. With regard of the non-blocking here, with non-blocking input output or input output request that returns immediately whether the requested input output has a completely occurred or not, and this allows the process to check the available data without getting hang completely if it is not there. And with reference to that only I will move ahead, because this is the difference between the blocking and non-blocking. So this is also an important, very important differentiate that they had asked you related to this unit 5 here. That is also an important one. Now we'll discuss another difference between that is related to the block device and the character devices. Block devices and character devices is also important, that they had asked you many times in the question paper here. So now we will discuss the block device and the character device here. Block devices and character device, these are the differences that is important to understand, and important they had asked you as well. Block device क्या होता है? A block device is one with which the driver communicates by sending entire blocks of data. ये block device जो होता है वहाँ पे आपका जो driver होता है वो communicate करता है और send करता है blocks of data उसको. Character devices जो होते हैं, the character devices is one with one the driver communicate by sending and receiving the single date character here. तो यहाँ पे क्या होता है, कैरेक्टर डिवाइस में जहाँ पे ड्राइवर जो है वो कम्युनिकेट करता है, सेंड भी करता है प्लस रिसीव भी करता है सिंगल कैरेक्टर्स को. The second difference between the block device and the character devices that we have is the block device access the disk using the system normal buffering mechanism. Block device जो होता है वो आपका access disk को तभी करता है जब आपका वो system normal buffering mechanism को use करता है. The character device provides the direct transmission between the disk and the user's read or write buffer. Character devices जो होता है वो आपका direct transmission provide करता है as well as between the disk and the users that can read or that can write the buffer here. Moving ahead with the third difference between the block devices and the character devices that we have to discuss here is examples of block devices. अगर हम examples की बात करते हैं block devices की, so the examples of block devices we have is hard disk, USB cameras and disk on the keys here. These were the three examples of block devices: hard disk, USB cameras and dead disk on the keys here. The examples for the character devices we have as serial ports, parallel ports and as well as sound cards here. Okay, these were the three examples related to the character devices. In the block devices, if I'm talking about so read only block of data, जो block device है वो सिर्फ और सिर्फ block of data को ही read करता है, but जो character devices है that read the data character by character, और जो character device है वो character by character read करता है data को. In the block devices here, these devices can be accessed randomly. ये जो block devices है वो आपकी devices ऐसी devices हैं जो कि access randomly होता है. And with reference to the character device, these devices are accessed only serially or sequentially. और ये devices ऐसी हैं जो कि आपकी access की जाती है serially या फिर sequentially. Now we'll discuss moreover about the DMA. That is also an important and very important topic related to, if I'm talking about the related to the course. The DMA has been asked many times, and that is also an important topic that we have to discuss in related to this topic here. Direct memory access. पहली बात तो DMA का full form क्या होता है? D stands for direct here, as I had written here, direct memory and access. So direct memory access, this is the direct memory access. Here we'll discuss the direct memory access. DMA is an input output technique that allows a control unit to directly access the main memory. This means that at once a reading or writing that began the remainder of the data can be transferred to and from the memory without processor or CPU intervention. बेसिकली क्या होता है, जो डायरेक्ट मेमोरी एक्सेस है जिसे हम डीएमए कहते हैं, वो एक आपका इनपुट आउटपुट टेक्निक है जो कि आपका कंट्रोल यूनिट को अलाउ करता है कि वो डायरेक्टली एक्सेस कर सकता है मेन मेमोरी को. इसका मतलब ये कह सकते हैं हम कि जब आप एक बार रीड कर रहे हो या राइट कर रहे हो, आपने शुरू कर दिया तो रिमाइंडर जो होता है डेटा का, दैट कैन बी ट्रांसफर टू या फिर टू ईदर टू और फ्रॉम विदाउट द मेमोरी प्रोसेसर दैट द सीपीयू इंटरवेंशंस है. विद रिलेटेड टू डीएमए में हम उसके डीएमए ब्लॉक डायग्राम भी पढ़ने वाले हैं, एज वेल एज रिलेटेड टू दैट वी विल डिस्कस मोर फर्दर हियर. This is a diagram of the DMA. We'll discuss about the DMA and then we'll discuss more about the DMA here. Without DMA, first you have to understand some of the points related to the DMA here. That is direct memory access. Without a DMA, the processor is responsible for the physical movement of the data between the main memory and the devices. A special control unit may be provided to allow the transfer of block of data directly between an external devices and the main memory. Without continuous interventions by the processor, this approach is called a direct memory access. Where the direct memory access, that is the DMA basically, that DMA can be used with either pooling or interrupt software. That shows the typical DMA block diagram we'll discuss here, that you can see here in the screen. DMA is particularly useful on the dead devices like a disk, which or maybe bytes of information that can be transferred to a single input-output operation. When used in the conjunctions or with an interrupt, the CPU is noticed only after the entire block of data has been transferred. For each byte or word transferred, it must provide the memory address and all the bus signals that controls the data transfer as well. With reference to this, you can just go through with the diagram here, and that where you can see understand about the diagram. This is the data unit here, and this is the data line. Data lines has been gone to the data unit here, where the data registers, this data lines has been gone to the data register here. This is the address register. Data lines has been gone through with, but that is coming from address lines here. And here this is a control logic here. Control logic, there DM REQ, DMA REQ, that is direct memory access request, and that is the another DMA back ACK, that is the direct memory access acknowledgement, and that enter. Then read, and then read goes towards it, and write also goes toward to control logic, and what it comes is INTR and the DMA request here. With regard of this is a DMA block diagram here. Now we'll discuss the difference between the traditional input output and a DMA. The traditional input output की अगर हम बात करते हैं तो you can see here with regard of the traditional, that is the first figure that is the traditional here, and after that the second figure that you can see here as possibly that is your this is the DMA here. In regard of the traditional, the main memory goes to the CPU goes to the input output controller, and that goes to the input output devices. Then in return, input output devices to the input output controller, and then it goes to the CPU, and then it goes to the main memory. This is the traditional method, you can say that traditional traditional input output. Okay, and this is what I'm talking about the DMA, that is direct memory access. Main memory ऐसे आपका input output controller में गया, and that it goes to the input output device, it returns towards it, and then input output controller से आपका main memory में गया. जब ये main memory से input output controller जा रहा था तभी आपका CPU में चला गया. CPU में जाने के बाद वो आपका that it connects to the same main memory से जब input output controller से जा रहा था. फॉर द रेफरेंस ऑफ दिस, जब इनपुट आउटपुट कंट्रोलर से मेन मेमोरी में जा रहा था डीएमए में, तो क्या हो रहा था, that goes to the CPU and that it returns and connected to the main memory. So this is the process which we are using, that is direct memory access, and that is CPU. यहाँ पे देखो इंटरजेक्शन यहाँ पे 4 पार्ट्स में डिवाइड होते हैं, यहाँ पे इन कॉमन है, वो एज अ लाइन सिग्नल पे ही वो पास ऑन हो रहा है, जाने टाइम पे भी और आने टाइम पे भी. This is what the DMA is used for. Operations of DMA that you can see here as the following, the sequence steps that takes place, that DMA transfer that we'll discuss here with another figure, that is that DMA operations here, and that we have to discuss, and that we go ahead here. So here as you can see that this is a DMA operation diagram where the CPU is there, and that is the first operation that has been gone to the DMA controller. Then after that it will join a line here, and that it will goes towards the internal buffer, and that is what disk controller, and from the disk controller it goes to the DMA controller here, and from the DMA controller it goes to the CPU as well, and it from the internal buffer it goes to the main memory as well, and that it goes towards the disk from the internal disk controller, and from the disk it goes to the disk controller, and disk controller towards the disk here. This is the DMA operation where you can that has been performed here. With regard of this, you can understand that DMA controller is a program by the CPU, and it registers and the set to require the operation. It issues a command to a DMA controller for reading data from the secondary storage disk and store it in the internal buffer. It verifies the checksum. If the disk controller buffer controls valid data, then DMA operation starts, where the data transfer is start by the disk controller by issuing the read request over the bus, and the DMA controller then puts the memory address on the bus here, as you can see. And with respect to that, this controller fetches the next word from the internal buffer, and it knows where to write it. Writing to memory is another bus cycle, and the disk controller sends as acknowledgement, as you can see, to the DMO controls when writes complete. DMA controller that increments the memory address to use, and the data that decrements the byte count, and the step 2 and the 4th that has been repeated until the byte count reach to the 0, that what we had discussed about, like the data transfer is to start off by disk controller and issuing the read request over the bus, and the DMA controls then it puts towards the memory address on the bus, and the second fourth one will like disk controller sends an acknowledgement to the DMA controller when that writes completely. So the DMA controller interrupts the CPU to know that the transfer is now complete, that what the DMA operation has been performed here. Now moving ahead with another topic, and that what we have to discuss here is your input output buffering, and that is also an important here. With regard of input output buffering, here you can see that input output buffering, as you can see, input output buffering क्या होता है, that input output buffering, the buffering is a technique by which the device manager can keep slower input output busy, that during times when the process is not requiring input output operation. Buffering of input output is performed by the following reasons, and there are the three reasons, that is speed difference between the two devices, जो speed differences होते हैं दो devices के बीच में, data transfer size difference, जो data transfer size differences होते हैं, and to support copy semantics, और जो आपका support करता है copy semantics को, that is also done here. With regard of this, we'll discuss the types of input output buffering scheme. कितने तरह के आपके input output buffering schemes होते हैं, तो तीन तरह के होते हैं. पहला होता है सिंगल बफरिंग, दूसरा होता है डबल बफरिंग, एंड तीसरा होता है सर्कुलर बफरिंग. तीनों के बारे में मैं पहले थोड़ा थोड़ा बता देती हूँ कि सिंगल बफर क्या होता है, दैट इज ऑपरेटिंग सिस्टम असाइंस अ बफर इन द सिस्टम पोर्शन ऑफ मेन मेमोरी. डबल बफर में क्या होता है, like the one the buffer is for the driver or the controller to store the data while waiting for it to be retrieved by the higher level to the hierarchy, and the buffer is to be stored data from the lower level module. And circular buffering जो होता है, that is when more than two buffers are used, and the collections of the buffer itself refers to the circular buffer. Yeah. So now we'll discuss about the single buffering. And what a single buffering is. Single buffering is operating system assigns a buffer in a system partition of main memory. In single buffering, operating system assigns a system buffer to the user request as well as So here that input output transfer that made by the buffer, that is block, moved to the user space when needed. Swapping can occur since input output is taking place in the system memory. That user memory operating system keeps the track of the assignments of the system buffer to the user process as well. This is all about the single buffering here. Now we'll discuss about the double buffer here, and the double buffer stands for like one, a buffer is for the driver or the controller to store the data while waiting for it to retrieve the higher level of the hierarchy. And even though we can say that that other buffer is also to share the data from the lower level module. In a double buffering, if we are talking about in double buffering, that the process consumes from one buffer while the system fills for the next, and a process can transfer data to and from one buffer while the operating system empties or fills the upper buffer also. तो डबल बफर में क्या होता है, बेसिकली डबल बफरिंग क्या होता है कि जब आपका जो प्रोसेस होता है वो कंज्यूम करता है ऑफकोर्स एक बफर को एक टाइम पे, तो तब क्या होता है, तो वहाँ पे वो फिल हो जाता है, वो दूसरे को फिल करता है, दूसरा फिल होता है, एम्प्टी होता है, तो फिर तीसरे को फिल करता है, तो इस तरह से वो बफरिंग फिलिंग होती रहती है। इस वजह से डबल बफरिंग यूज होता है। विद सर्कुलर बफर की अगर बात करते हो तो सर्कुलर बफर स्टैंड्स फॉर व्हेन मोर देन टू बफर्स आर यूज, जब एक से ज़्यादा, दो से ज़्यादा बफर्स एक टाइम पे यूज़ कर रहे होते हैं, तो द कलेक्शन ऑफ द बफर is itself referred to as the circular buffer. तब आपका जो collection होता है, that is referred to as circular buffer only. Now moving ahead with another topic, and that would we have to discuss about the selection criteria for selecting the disk scheduling algorithm. तो हम क्या selecting criteria हैं जिसको हम use करते हैं, एक selecting criteria को use कर रहे हैं, for that selecting those the disk scheduling algorithm. So basically the actual detail of the disk input output operation depend on the basically the three here. There is the computer system, that is second is your operating system, and the third one be nature of the input output channel and the disk controller hardware. Currently the disk are at least of the four orders of magnitude slower than the main memory, and that will general timing we can see the disk input output transfer diagram. You can go ahead with the diagram that we had mentioned here. So here this is a diagram as you can see, and this is waiting for a device, waiting for a channel. This is the seek time, and this is the rotational delay. This is the data transfer, and this from waiting for channel till the data transfer. This is the device phase here. This is the disk input output transfer timing that as mentioned what I'm talking about. The disk is rotating at a constant speed when it performs read or write operation. To read or write to the head must be the positioned at the desired track, and at the beginning of the desired sector on that track. Head is moving from the one track to the other track for the selecting the proper track. And where I'm talking about the track selection, so track selection involves moving the head in the movable head system or electronically selecting one head over a fixed head system here. So we'll following parameters are to be used for the disk performances. So they are the three, that is your seek time, rotational delay, and the access time. With reference to the seek time, if I'm talking about, so seek time we'll discuss here. Regard of the seek time, the time it takes to position the head at the track is known as seek time. जो time आपका position head का position को change करने में लगता है, that is what that track of that head is known as the seek time. When you are finding out the seek time, you can just say that seek time equals to number of track traversed multiply the disk drive constant plus your startup time. This is the formula to find out the seek time of any that positions of a head when you are tracking some track that particular head, and with respect to the time here. In reference to the seek time do not apply to device with a fixed read or write heads. So now we'll discuss about the rotational delay here. The rotational delay is the time taken for the beginning of the sector to reach the head is known as rotational delay. So that a time that is taking to the beginning of that sector to reach that head is known as rotational delay. Well, it is also known as the search time as well. रोटेशनल डिले को हम सर्च टाइम भी बोलते हैं. Now we'll go ahead with SS time here. SS time क्या होता है? The sum of the seek time and the rotational delay is equals to the SS time. तो जब आप SS time निकाल रहे होते हो तो आप rotational delay as well as seek time को add कर लोगे. We'll find out the SS time here. So SS time equals to seek time plus rotational latency and rotational delay, we can say that. So that we'll find it out your SS time here. Now moving ahead with another one, and that will discuss about the transfer time as well as the disk capacity that we have to discuss. Here the transfer time, if I'm talking about the transfer time, so transfer time is equals to number of bytes to be transferred upon number of the bytes on the track multiplied by the rotational speed. This is the formula you are finding out the transfer time when you're getting to finding out the transfer time here. Now talking about the disk capacity, when you're finding out the disk capacity, so what is the formula? That disk capacity equals to number of the cylinders multiplied number of heads, number of sectors per sec track, and multiply by number of bytes per track. This is the formula to find out the disk capacity here. So this is the formula that you will use for the numerical as well as to finding out the number of the disk capacity as well as the transfer time here. Now moving ahead with a question here for the session, that is, suppose that a disk has 500 cylinders. The drive is currently serving a request at the cylinder 125 and the previous request was a cylinder 100. The request of the pending request is a FIFO in the first in first out order, that is 80, 147, 13, 177, 48, 409, 22, 175, 301. What is the total distance that the disk move for the following disk that for the schedule disk that scheduling algorithm? So हमें SSTF, look and C scan लगाना है. So SSTF के reference की अगर हम बात करते हैं, so when the total distance that the disk arms moves for the response to the SSTF here, 125, 147 here, then 175, 177, 80, 148, 20, 13, 301 and 409 here. With regard of the look, if I'm talking about, this has been asked in the many of the question paper, that is 2014 and 15 as well as they had asked you here. Luke की बात करती हूँ तो Luke is 125, 80, 48, 22, 13, 145, 175, 177, 301, 409. This is all the sum we have 408. इसका sum है 612 here. C scan की बात करते हैं, that is 125, 80, 48, 20, 2, 13, 0, 147, 175, 177, 301, 409. When we are adding on these things, so we are getting 534 as an answer here. Now we'll move ahead with another question, and that is your question, that is, suppose that the moving head disk with a 200 track is currently serving a request for the track 143 and has just finished a request for the track 125. If the queue of the request is kept in the FIFO, that is first in first or first out order, that is 86, 147, 51, 177, 794, 150, what is the total need a movement for the following scheduling? The options, the parts we have to find out: the FCFS and first come first serve, SSTF and C scan. This has been asked in the 2013 and 2014 question paper here, and that is also an important paper respect to the competition bias. So you can just gone through with the series here as well as you have to find it out. Move ahead with the solution here is, so we'll go ahead with the solution and we'll find it out for this particular question. This is FCFS हमें बोलना है, SSTF निकालना है, and then we have to find out C scan here. Okay, so we'll do the same here for this, and that is C scan. अब FCFS की अगर हम बात करते हैं तो उसमें हम देखेंगे next request कितनी है, and then first then we have your difference in head movement में difference कितना है. Okay, so we'll do that also, and SSTF के reference में भी दो parts में divide होगा, and first for the next request I will not write full, मैंने यहाँ पे लिख दिया already, reference in head movement हम लिख दे रहे हैं यहाँ पे, and then we have for next request as well as here we have next request के साथ साथ हमारे पास बनेगा difference in head movement here. Okay, तो इस तरह से मैंने इसको differentiate कर लिया. You can just do ahead and gone through with this, and you can also just find it out when you are solving all these questions. You have to make a table here with reference to this particular question here. Okay, तो ये आपका एक table format बन गया एक तरह से. Now we'll go with ahead with the solution. जिसमें अगर मैं FCFS की बात करती हूँ, विद रेफरेंस टू द FCFS की अगर हम बात करते हैं, so what we'll get in FCFS in the next request, we'll get 86 here. Okay, I will just draw a line so that you can differentiate between 86 आएगा, उसके बाद है then you have your 147. You can just go through with the question here, that then we have 91, then we have 177, and then we have 94, and then we have 150 in the next request for the FCFS here. For difference in the head movement, we have for 86 we have 57, 61, then we have 156 here, and then we have 86, and then we have here. So with regard of 86 here, after the 86, so we'll get here is 83, and then after that 83 we'll get here as 56. Now with reference to the SSTF, अगर हम next request की बात करते हैं तो we'll have 147, and then we have 150 here, and then we have 177, and then we have 94, and then we have 91, as well as we have here is 86. In terms of the difference in the head movement, here we have a 4, and then we have 3, then we have 27, then we have 83, then we have 3, and then we have 5. With reference to the C scan, the next request we have 147, then we have 150, then we have 177, then we have 0, then we have 86, 91, as well as 94. And for the difference in the head movement, we have here 4, this is 3, this is 27, then we have 177, as well as then we have 86, then we have 5, and then we have 3. According to this, we'll find it out for the solution, that total number of head movement in the FCFS, total head movements in the SSTF, and then total head movements in the C scan here. So we'll go ahead with that, and then we'll solve this. So here we'll go ahead with total heads if I'm talking about. So total head movements, or we have as you can see, total movements in FCFS. So we'll get here is 57 plus 61 plus 156, then we'll add on 86 and plus 83, then plus 56. That you can see here from the CFS की अगर मैं बात करती हूँ difference in head movement, so we'll go ahead and we'll calculate this, and we'll get 499. Now we'll go ahead total head movements with respect to the SSTF, so we'll add on these one, and then we'll discuss that total head movements in the C scan will add on this one. So just go through it and add on all these things, so that we'll get the answer as well. So total head movements in the FCFS, तो ये रहा. अब total head movements की अगर हम बात करते हैं, then we have a total head movements if reference to the SSTF here. So we'll get 4 plus 3 plus 27 plus 83, then plus 3, and then plus 5, then we'll get 125. Now we will go ahead, that is total head movement with reference to the in a C scan. So we'll get here is your 147 plus 150 plus 177 plus 0, then we have 86 plus 91 plus 94 here, and then we'll add on, we'll get a 745 as answer. Now moving ahead with another topic, and that what we have to discuss here is as follows. So as I made here that FCFS next request to head difference in head movement, this is 86, 147, 91, 177, 94, 150. Difference in head 57, 61, 156, 86, 83, and 56. This is SSTF, that is next request is 147, 150, 177, 94, 91, 86, and difference in the head movement, that is 4, 3, 77, 83, 3, and 5. C scan की बात करते हैं. Next request है 147, 150, 177, 0, 86, 91, and 94. Difference in the head movement that we have 4, 3, 27, 177, 86, 5, and 3. So as I told you that total heads movements in the FCFS is 57, and that what we had on plus 61 plus 156, 86 plus 83, and plus 56 we add on, this is 499. And then we total heads in the movement SSTF, that will add on 4 plus 3 plus 27 plus 83 plus 3 and plus 5, then we'll add on, this is 125 here. And total heads in the C scans, we add on these, and that is 4 147 plus 150, 177, 0 plus 86 plus 91, 94 plus equals to 745 here. Now we discussed more further, that is your disk scheduling algorithm policies, that what we have to discuss here. In reference to the disk scheduling algorithm, the disk scheduling algorithm are used to reduce the total seek time of any request. कोई भी request अगर आप कर रहे हैं तो उसका total seek time जो है उसको आप reduce करने के लिए disk scheduling algorithm या disk scheduling policies हम use करते हैं. Input output request issues a system to call the operating system. If desired disk drive or the controller is idle, then the request is immediately. And several scheduling policies has been given, but before that we have to know more about the scheduling. If the device is burst, then the request for the services will be placed in the queue of pending request, and when one request is completed, the operating system has to choose which pending request to be service next. And the processor is much faster than that the disk, so it's highly likely that there will be a multiple outstanding disk request, and before that the disk is ready to handle them, because disk have a non-uniform access time. Reordering the read request and can greatly reduce the latency of the disk request here. And move ahead with this. So where in this term we can say that non-uniform access time, that recording the disk request can that greatly reduce the latency of that disk request, as well as if I'm talking about the multiple requests when it comes, multiple requests to the disk will arrive while one of being serviced, as a disk scheduling increases the disk bandwidth as well. Now we'll discuss the several scheduling policies कि several scheduling policies कितनी हैं. तो there are the 6 several scheduling policies that we'll discuss one by one. This is the first one with the FIFO here. According to the FIFO here, that it stands for the first in, first out. So the FIFO stands for the first in first out. That FIFO is also called its first come a first serve. जो पहले आएगा उसे पहले served किया जाएगा. That is a first come first serve method here. Requests are proceed in the queue order. That a first come first serve has a fair policy in the sense that once the request has arrived, its place in the scheduled is fixed irrespective of the arrival of the higher priority request. This is what in the terms of FIFO here. Now with the second one, with that is your shortest seek time. For this हम SSTF बोल रहे हैं अभी तक. Shortest seek time first is that SSTF selects the next request at one requiring the minimum seek time for the current position. In the SSTF, we can say that the scheduling priority is given to those processes which need the shortest seek, even if these requests are not to be the first one in a queue. It means that all the requests nearer to the current head positions are serviced together before moving ahead to the distant track. Now we talk about the third scheduling policies that we'll discuss, and in all total we'll discuss the six several scheduling policies in terms of the scheduling policies here. So the third one will be the scan here, that is SCAN scan. This is the scan is also called as that this scan is known as elevator elevator algorithm also. An elevator algorithm के पूछे जाएंगे तो you can just define for the scan, and scan is an elevator algorithm. The next request schedule in the closest to the current request, but it in the particular direction. All the requests in other directions are put at the end of that list, and the scan services track in only one direction, as either in the increasing or the decreasing order in the form of the elevator here. Now the fourth one, if I'm talking about, the fourth one will be the circular scan, and the circular scan जिसे हम C scan भी बोलते हैं. Okay, this is the circular scan, and this is a C scan. Also moves the head in the one direction, but it offers the fairer services with a more uniform waiting time. It moves the head from one end of the disk to the other end, and servicing a request along the way. When the head of the reaches to the other end, it immediately returns to the beginning of the disk, and without servicing any requested on the return trip here. The fifth one, the fifth scheduling policy we have is look, that is LOOK. Look here. Look scheduling is the start the head moving in the one direction, satisfying the request for the closest track in that direction. When there is no more request in the direction, the head is traveling reverse direction, and repeat. This algorithm is similar to the scan, but unlike scan, the head does not unnecessarily travel to the innermost, outermost, that innermost and the outermost track on each of the circuit. Is that is what look stands for. If I'm talking about the next one, as you can see here with the next one, this is a C look here. जिसे हम circular look बोलते हैं, और हम इसे C look भी बोलते हैं. In the C look, that is circular look here, C look is the same as C scan. ये C scan के जैसा ही है लगभग, except the head stops after servicing the last request in the preferred direction. Then the services the request to the cylinder nearest the opposite side of that disk is. Now moving ahead with another question, and that is an also important question with reference to the question here. The question is very important because this has been asked in the 2011-12, and as well as in 15 and 16 here. And the question we have is explain the SSTF. जहाँ पे आपको explain SSTF और scan disk scheduling policies obtained by the total number of the moments needed to satisfy the following requests. SSTF और scan अभी मैंने just आपको बताया था, वहाँ से उसको लिख सकते हो, and you get to know about all these things. And the track of the request for each of the two policies we have is 27, 129, 110, 186, 147, 41, 10, 64, 120. Assume that the disk head is initially positioned over the track, that is your 100 here, and that is 100, and is moving in the direction of decreasing the track number. And now we'll go ahead with the solving with respect to the SSTF as well as with respect to the scan here. So we'll form a table here to solve this, and we'll just go ahead with the solution here. So here for the SSTF, if I'm talking about SSTF के बारे में, तो सबसे पहले हम जो SSTF के बारे में निकालेंगे, that we will do make a table here, that is next track पहला आपको बनेगा जो वो next track assist के बारे में बनेगा. And then you have another column here, that is with reference to the number of track traversed. So track traversed के बारे में बनेगा, and with regard of that we'll make this two separate columns here for finding out the answer here. So we'll go ahead with this, and I will just find it out, and as well as you can also draw this table to find it out of this. So next track assessed and the number of track traversed के बारे में बात करते हैं. तो we'll have a data here, and that will in the terms of जैसे कि 110 SSTF में आपको बोला गया था जो shortest seek time होगा, हम उसके हिसाब से इसको लेके चलेंगे. And then accordingly we have 110 first, and then we have 120, Then we have 129, 147, 186, and then we have 64, 41, 27, and then we have your 10 here, and then we have here is your total track traversed. Okay, so this is the total track traversed. We will go ahead and I will just we will be finding out कि कितना total track traversed हुआ है. So यह अगर मैं बात करती हूँ number of track traversed के बारे में, तो 110 के लिए जो track traversed है that will be the 10, 120 के लिए 10, and 129 के लिए 0, that is 9, and 147 के लिए 18 here, and 186 के लिए 39, and 64 के लिए 122, and then we have 41 के लिए 23, and 47 के लिए 14, and 10 के लिए 17, and in all total अगर हम join करते हैं 9 plus 8 that is your 17, 17 plus 18 19, and 19 plus 19 and 20, 20, 20, and that is 29, 29, and the 31, 31 plus 4 here, 31 plus 4 35, 35 plus 7 that is your 42. तो 2 यहाँ पे और 4 कैरी हो गया. 4 plus 1 5, 6, 7, 8, 9, 10, 11, 12, and 13, 14, 15 and 16. तो 6 यहाँ पे 1 कैरी हो गया, एंड यहाँ पे थर्ड डेसिमल एक यहाँ पे एक ये है और एक ये है, तो 1 और 2, 1 plus 2 that is 2. तो हमें टोटल ट्रैक ऑफ traverse that is 262 मिल गया. This is with reference to the SSTF here. Now we'll go ahead and we'll form a table with reference to the scan here, जो कि इन्होंने खुद बोला है कि आपको फाइंड आउट करना है. For that we'll make a table here another. So now we will make for the scan here, and that is your scan. इसमें भी दो tables बनेंगे आपकी. So we'll just make that one here. And पहला आपका होगा कि पहला table जो बनेगा that is your next track assessed जो बनेगा. Okay, and this is the first column here, and the second will be your number of track. Okay, so number of track traversed जो होगा वो हमारा बनेगा, and that will be here. So we'll just make it a table here right now, so that we'll get the answer. And this is how you can make a table. This is the two column which will make in the form of scan as well as SSTF here. So next track access and number of the track traverse की बात करते हैं. So here with the data we have is your 64, then we have your 41, then we have 27, and then we have your this 10, and then we have 0, then we have 110, and then 120, 129, 147. Okay, it is not visible, so 147. Then we have 186 here, and then we have here a total track traversed. Okay, so we will go ahead and just solve it out and then find it out the answer as well. So here we have this for the 64, if I'm talking about, so 64 the number of the track traversed is your 36. Then for 41 this is 23, 27 के लिए 14, 10 के लिए 17, 0 के लिए of course 10, 110 के लिए was same as 110, 120 के लिए this is 10 here, and then of course we'll have 9 for the 129, and then for 147 के लिए 18, and then 186 के लिए this is 139, and then we have a total here that is 9, 9, 18, 18, and then we have 26, 26 plus 7, so 26 plus 4, that 30, 37, and 37, then 38, 39, 40, 46. So we'll have a 6 here and 4 carry, as you know, and we'll just add on 4 plus 3, that's 7, 8, 9, 10, 11, 12, 13, 14, and then we have 15 and 16, 17, 18, so 8 यहाँ पे रहेगा, 1 carry here, 1, and then we have a 2 here, yeah, 2, and then 3 here, so 3 will be this 386. The total track traverse जो होगा that is 386 will be that. Okay, so this is what we had find it out for the sequence of the track that requests for each of the two policies, SSTF as in scan. We had made a table here, and that is also important. You can just make it and you can just write it down. Moving ahead with another question, and that what we have to discuss here. So here this is the another question that we have to do, that is, your suppose a disk have 5000 cylinders numbered 0 to 4999. The drive is currently sending a request at cylinder 143 and the previous was the cylinder 125. The queue of the pending request is your, that is fast in fast out, जो fast come fast serve वाला, and order is 86, 1470, 913, 1774, 948, 1509, 1022, 1750, and of course 130 here. So we'll make a table here for the reference जिसमें हमें disk request as well as the first come first serve, SSTF look and scan हमने देखना है. सारी चीज़ों के लिए लिएंगे तो उसके लिए इंपॉर्टेंट क्वेश्चन है 2009 एंड 10 में आया था. उसके बाद आपका ये भी 2017 और 2018 में आया है. Go ahead with the table here and we'll form it out, the table here. This is the disk request. We can just write it down, disk request here, and then we have here another one, that will be the FCFS. FCFS में दो आपका आएगा, एक होगा next track, आपका next track, and this is the another one, that is your number of track, and that is number of track traversed. Okay, so this is for the FCFS. Then we have for SSTF के लिए भी यही होगा, and next track, and then a number of number of track traversed. Then for the another one we have look के लिए भी same रहेगा, and that is for the next track, and then we have your number of track traversed here. उसके बाद हमारे पास C scan के लिए भी होगा. C scan के लिए will made here only, so we'll just shift it out little bit. Okay, so that we'll get the answer here. तो disk request हमने जो यहाँ पे कर लिया है तो already थोड़ा सा space ले लिया. Let's go ahead with this only, and then we'll write it down for the disk, for the C scan also. So we'll just go ahead and solve this further here, and we'll just make a sort of a table here. This is what it is all about. Okay, so this is a table here. So disk request की अगर हम बात करते हैं तो disk request is of first is your 86 जो कि already इन्होंने दिया हुआ है, and then we have 1470, then we have 913 here, then 1774, then we have 948, then we have 1509, and then 1023, 1750, then 7 that is 1750 here. Okay, after that 1022, and then we have another one, that is your 1750, then we have 130 here, and then we have a total head movement. Total head movement is total head movement here. Okay, so इसके accordingly हम इसको solve करेंगे. So we'll go ahead here, and then we'll find it out the answer as well. Then if first come first serve, this is that is shorter 6 time first के बारे में, then look, and then see look here. C scan के बारे में हम already find out कर रहे थे, तो just we'll find out for these three, and then we'll find out the rest of them. फर्स्ट का फर्स्ट सर्व के लिए अगर हम 86 की बात करते हैं, नेक्स्ट जो आपका ट्रैक होगा, इट विल बी द 86 here, and then for 1470 that will be the same here, and for the 913 that is also the same, 1774 is the same, 948 same, 1509 and 1022, 1750 and 130, this will all be the same as what the disk request has been given here. Okay, so we'll go ahead, and we'll just write it down like this, what they had given you, and accordingly we perform. So this will be that, and the number of the track traversed में आएगा 86 है जब first come first serve है, so the first track will be the 57, then 1384, and then we have your 557, then we have 861, and then of course we have here is with regard of that we have 826, and then we have 561, and then we have 4, that is your 561, then 487, then we have 728, and then we have 1620 here. We'll just add it on, and then we'll get, what we'll get is 7 plus 7 7 14, and 14 plus 115, then 19, and 19 plus 625 26, and 26 plus 7 here, and that is your 26, that is your 33, 33 plus 8, that is 41. So 1 यहाँ पे 4 carry, and then यहाँ पे 4 plus 1 5, and 5 plus 8, that is 13, 13 plus 5 18, 18 plus 6, that is your that is 24, 24 plus 2 26, 26 plus 26 plus 6, yeah, 26 plus 4 की अगर हम बात करते हैं तो that will be the 30, 38, and 38 plus then we'll go ahead 38, then we will get heading this, and then we will have this and this. 7801 will get for the first come first serve here. That is the total head movement. With regard of SSTF की अगर हम बात करते हैं, the next track will be as accordingly, that will be the 130, then 86, and then we have 913, 948, then we have 1022, 1470, then we have 1509, and then we have 1750 and 1774 here. With the number of the track for the SSTF, we will be finding out that will be the 13 here. This is 44, then 827, and then we'll get 35, and we'll get 74, and then we'll get 440, like accordingly, that what we'll get is 74 के बाद 448, and then we'll get 39 here, and then we'll 41, and then 24. जब हम इसको add on करेंगे, so we'll further move on and we'll get 1745. We can just add it on. And for the next look के बारे में बात करते हैं, so next look के लिए that will be the next track, and that look के लिए that is your 913, then a 948, and then 1022, 1400, 70 here, 1500, and your 9, then 1750, then 1774, and then we have 130, and then we have 86 here. And the number of track traversed will be the, for the look will be the 770, then 35, 74, then 448, 39, 841, 24, and 1644 here, and then we'll have 44 as well. जब इसको sum up करेंगे, we'll get 3319, that is 3319. This is for the look. अब हम C scan के लिए भी करेंगे. सो सी स्कैन के लिए अगर हम यहाँ पे थोड़ा सा शॉर्ट थोड़ा सा बचा हुआ है, तो मैं यहाँ पे एक बार करके दिखा देती हूँ आपको. ओके, फॉर दिस सी स्कैन के लिए अगर हम करते हैं सी स्कैन के लिए, सो व्हाट विल गेट हियर इज इन द फॉर्म ऑफ नेक्स्ट रिक्वेस्ट पहले हम बनाएंगे, दैट इज नेक्स्ट ट्रैक, एंड देन वी हैव अ नंबर ऑफ दैट विल बी द ट्रैक ट्रैवर्स्ड हियर, सो विल डू दैट हियर सेम एज वेल. We'll go ahead, and क्योंकि वो थोड़ा सा छोटा बनेगा, तो so we'll be having a number of track many times. Okay, so then we have NT, then number of track traversed, and then we have same for NT, and then we have number of track traversed. Okay, so accordingly we will do that, and then we have here is for the number of tracks, we'll write it on first, that is your 913, and then we have a 948, and then 1022, and then we have 1470 here. And for here we will write it down, that is 1509, 1750, and 1774 here, and then in 499 here, 4999, and then we have 0 here. Then again we have is 86 here, and then we'll find it out कि total number of कितना आया है, total heads of कितना आया, that is 130 here. And now we'll find it out for the number of that is track traversed, that is 779, and then we have 35, 74, then 448 here, and then after that we have 39, 41, 24, and then we have 3225, then we have 4999 here. And for the 86 we have here is your this is same as 86, and 130 के लिए that is will be the 444 44. So we'll add on all these number of track traversed here, so we'll add on, and then what we'll get here as an answer. So here we'll write it down, the total head movement that we will be getting here when summing all that will get 9785. So this is what we will receive when 500 cylinders were numbered from 0 to 499, and that has been solved here. So now moving ahead with another question, and that we will solve with related to that. This is all important, as I told you before also. You can just gone through with that and you can just achieve that. This is important, and that has been asked in the examination paper, that what I had made you right here. So now moving ahead with another question is, so here we can see that another question, that is the none of the disk scheduling disciplines except first come first served is truly fair, that is starvation may occur. So the first question they had asked you is, explain why this assertions is true, क्यों ये assertion true है. And for that we have an answer is, new request for the track over which the head currently reside can theoretically arrive as quickly as these requests are being serviced. So that's the reason why this assertion is true here. Moving ahead with another question, the question we have is, describe a way to modify algorithms such as a scan to ensure the fairness here. So for that sake, we have answer here, that is, all requests older than some predetermined age could be forced to top the queue, and the associated bit for each need of these requests for the SSTF, the rest of the queue would have to be recognized with respect to the last of these old requests here. Now moving ahead with another question, that is your, explain why fairness is an important goal in the time sharing system. क्यों टाइम शेयरिंग सिस्टम में फेयरनेस एक important गोल रोल प्ले करता है. So here the answer is of one line only, that is to prevent unusually long response time, कि हम prevent कर सके जो unusual long response time है उसको prevent करने के लिए आपका use होता है. The next, moving ahead with another question, and that is with related to this, that is the last question, that is, give three or more examples of the circumstances in which it is important that the operating system be unfair and serving input output request here. With regard of that, the fourth one we have is, paging and swapping should take priority over user request, and it may be desirable for other kernels initiated input output, such as the writing of a file system metadata, to take the precedence over the user input output. If the kernel supports the real-time process priorities, the input output request of those processes should be fairness. So now moving ahead, that favored actually, and then moving ahead with another question that we have to discuss here is, so here we have a difference between the RAID 0 and RAID 1 level here. So RAID 0 क्या होता है? RAID 0 refers to the disk array with the striping of the level block but without any redundancy, that is RAID 0 level 0. And RAID 1 की बात करते हैं, that is RAID 1 layer is the RAID is implemented in the two ways, that is the software RAID as well as the hardware RAID. But अगर RAID 1 की बात करते हैं तो that is refers to the disk mirroring and the redundancy that is achieved by just duplicating all the data here. So we'll go ahead with the RAID. कि RAID क्या होता है? First of all we have to know about this. So RAID means redundancy array of independent disk. It consists of multiple disks. It provides the data protection against the hard disk of failure as well. So in the case of the RAID की अगर हम बात करते हैं, and that provide the protection and the hard disk failure as well. And RAID implementation, before discussing moreover, we have to know some of the points related to the RAID here, that as I told you, RAID is a full form of redundant array of the independent disk here, and that is the RAID implementation improves the input output performances of the storage system by storing data across the multiple hard disks, and the data is organized in the multiple ways. Because of many hard disks, data is stored as several disks instead of the single disk here. And RAID capacity depends only upon the types of the RAID array. User build the number of the size and the number and the size of the disk drives as well. If I'm talking about the RAID consists of 7 layers, where the RAID is implemented in two ways, and the two ways is your software RAID as well as the hardware RAID. And according to that, the software RAID क्या होता है? Basically, software RAID runs on the server processors, that is CPU. It's implemented as an operating system level here. Okay, that is the software RAID. But for the hardware RAID here, the hardware RAID is implemented in the two ways. पहला होता है स्पेशलाइज्ड हार्डवेयर कंट्रोलर ऑन द सर्वर एंड द स्पेशलाइज्ड हार्डवेयर कंट्रोलर ऑन द array. ये आपका जो होता है, ये आपका जो है वो स्पेशलाइज्ड I will just write it down here. Specialized that is your specialized hardware controller in the on the server, and this is also implemented by the specialized hardware controller on the array. Right. And for the software here, and that is that is the server processor जिसको कि आपका रन होता है server processor पे. Here I can write it on that also, server processor at the operating system level. कौन से level पे? Operating system level पे. Okay, so with reference to that, RAID array consists of, so where we can see that RAID RAID array consists of the multiple hard disk with the required hardware and the software. Hardware and the software is required for the implement that the RAID array. And it is also consists of the physical array and as well as logical array. With regard of that, we have in RAID 0 level 0. In RAID level 0, the data is split into the block data that are written across all the hard disk in the array. It utilizes the full storage capacity on the hard disk, and it creates one large virtual disk from the number of the smaller disk as well. In the RAID level 1 की बात करते हैं, that is also known as, इसे हम जो RAID level 1 है इसे हम mirroring भी बोलते हैं. Okay, so mirroring भी एक short note पे पूछा जाता है. तो RAID level 1, that is also known as mirroring. It writes all the data two times, that is once in the main hard disk and the once in the mirror as set as hard disk here. Because of the mirroring, it improves the fault tolerance. Each drive is the mirror contains an identical copy of the original disk data. Where the reference to the disk RAID level 2, where in RAID level 1, that is refers to the disk mirroring, and that is the redundancy achieved by the just duplicating all the data here. But regard of the RAID level 3 here, that in the RAID level 3 RAID level 2 here, so RAID level 2 that uses the concepts of parallel access technique here, and it works on the word that is in the byte level. And so each stripe stores one of bit, and as well as it takes the data striping to the extreme, writing only one bit per stripe instead of an arbitrary size block. For this reason, it requires a minimum of 8 surfaces to write data to the hard disk here. For the RAID level 3 की बात करते हैं, that is also called as bit interleaved here. So we'll just write it down. Bit interleaved parity organization. So bit interleaved partially parity organization, it uses the single parity bit for the error correction and for the error detection as well. It also reads and writes complete stripes of data that across all the hard disk as the hard disk operate in the parallel. We are talking about the RAID level 4 here, that maintains the separate hard disk and the parity bit. The parity bit is also stored on the block. That parity block improves the fault tolerance as well. I'm talking about the RAID level 5 here. So in the RAID level 5 array are the stripes at the block level, and that uses the XOR and then ACC parity, and that is parity is distributed across all the hard disks, and that distribution of the parity stripes across the hard disk, as well as that avoids a potential input and output bottleneck of the single parity disk here. If I'm talking about the RAID level 6 here, that is the attempts to protect against the multiple disk of failure by using the two sets of the error correction stripes for each row of the drives. One stripe hold the parity and the other stores the read Solomon error correcting codes. Now moving ahead with this, Here the various disk scheduling methods है, हम various disk scheduling जो कि 2 मार्क्स में पूछा जा सकता है कि various disk scheduling methods कौन कौन से हैं. तो पहला है first in first out, SSTF, scan, C-scan, look and C-look. These were the various disk scheduling method that has been used here. Now moving ahead with another one, that is your seek time for a hard disk management mechanism. So seek time for a hard disk mechanism here. The seek time is the time required to move the disk arm to the required track. Required track disk arm जो है, that is the seek time is the time required to move the disk arm to the required track. And for the latency time for the hard disk mechanism here, latency time क्या होता है? It is a time spent waiting for the target sector to appear under the read and write head. That you can define the latency time for the hard disk mechanism here. Moving ahead with another one that we'll have to discuss here. Here we have another one, that is a mirroring here, and a mirror is a set comprises two equal size partition on two disks. So when an application writes the data to the mirror set, it disk writes content of the two partitions are identical here. Now we'll discuss the responsibilities. They can ask you about the 2 marks here. That is the responsibilities of operating system in the connection with the disk management. So these were the 3 responsibilities that of OA operating system in the connection with disk management here. The first responsibility is free space management, जिसमें आपका free space management होता है, storage allocation and the disk scheduling. These were the 3 responsibilities of operating system in connection with the disk management here. Now moving ahead with another one, की need of disk scheduling. क्यों need पड़ी हमें disk scheduling की? This is also asked in the is of 2 marks here. For a multi-programming system with many processors, the disk queue may often have a several pending requests. Thus, when one request is completed, the operating system chooses which pending request to service next. To reduce seek time and increase the disk bandwidth, disk scheduling is required. Next is your rotational latency. Rotational latency क्या होती है? The time to wait for a target sector to rotate underneath that head. It is additional time waiting for the disk to rotate the desired seek to the disk head here. This is known as rotational latency here. Moving ahead with the swap space. Swap space क्या होता है? The swap space is the secondary memory is a swap device. Secondary memory एक swap device है, and the section of the disk used for this purpose is known as swap space. और ये section जो use हम करते हैं disk को like swap device के तरह, जिसे हम secondary memory के regard में use करते हैं, that is what known as this purpose is known as all about swap space here. Moving ahead with another one that we have to discuss here is, with regard of this, we had completed your unit 5, most of that, half of that unit we had discussed here. And अगर हम बात करते हैं with reference to the operating system here, so we had completed unit 1, unit 2, unit 3 and unit 4 as well. And unit 5 में भी हम half of the topics discuss कर चुके हैं, जिसमें हमने unit 1 में introduction operating system and functions, classification of the operating system, batch interactive system, time sharing, real time sharing, as well as multiprocessor system, multi-user system, multi-process system, multi-threaded system, operating system structure, layered structures, system components, operating system services, rehenent kernels, monolithic and microlithic systems here. That's what we had discussed here. Then after in the unit 2 we had discussed about the concurrent process concept, principles of concurrency, producer consumer problem, mutual exclusion, critical section problem, Decker's solution, Patterson solution, semaphores, test and sets operation, classical problem in the concurrency, dining philosopher problem, sleeping barber problem, inter-process communication models and schemes, and process generation. That what we had discussed in the unit 2. Unit 3 की बात बताते हैं, तो unit 3 में we had discussed about the CPU scheduling here. Here we have CPU scheduling में हमने discuss किया scheduling concept, performance criteria, process state, process transition diagram, scheduler, process control block, that is PCB, and the process address space, process identification information, threads and their management, scheduling algorithm, multiprocessor scheduling, deadlock system model, and then deadlock characterization, prevention, avoidance, and the detection, recovery from the deadlock. That what we had discussed here. Then we had discussed unit 4, that is memory management. That's the basics of a machine, and that is resident monitor, multi programming with a fixed partition, multi programming with variable partitions here.
So that we had discussed the fixed partition as well as multi-programming with a variable partition, projection scheme, paging segmentation, page segmentation, virtual memory concept, demand paging, performance of the demand paging as well as page replacement algorithm, thrashing, cache and memory organization, and locality of the references. Then we had start discussing about unit 5 जो आज की क्लास में हमने डिस्कस किया है, and that is input output management and the disk scheduling. And here we had discussed input output devices, input output subsystems, input output buffering, disk storage and disk scheduling. RAID file system already we had. So here we had done this also in the RAID file system, file concept, file organization and access mechanism, file directories and the file sharing, file system implementation issues and the file system protection as well as security here. So class आज के लिए इतना ही. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe to our channel so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Hope you enjoy this video. Please like, share and subscribe our channel. Thank you.